So this exercise is related to work, energy, and power. I have given you exercise 2 as a homework this week. Exercise 1 is all about MCQs, multiple choice questions. You can also use the chat to answer. Energy is released in some, I will discuss each question, but you can also use the chat to answer. Energy is released in some nuclear reactions. Which nuclear reaction take place in a nuclear power station and which take place in the sun? So nuclear power station is a fission, and on the sun it is fusion. So fission and fusion, so it match with option B. I'll try to discuss many questions in this one, so you can also use the chat to answer at the same time I'm discussing with you. The next one is, as it because it's an important topic, so I want you to understand like how certain type of questions you will solve. A lorry of mass 4,000 is traveling at a speed of 4. A car of a mass 1,000 moving at have the same kinetic energy. What is the speed of the car? So they said that the kinetic energy of the lorry is same as the kinetic energy of the car. What's the formula to get the kinetic energy? Kinetic energy is half mv square. So half mv square for the lorry will be equals to half mv square for the car. So it will be half. M is the mass of a lorry, which is 4,000. V is the speed at which it is moving, that is 4 square. This will become half. The mass of a car is 1,000 and the speed we don't know. Now we simplify. Now it's like mathematical equation. Your subject is V and then V square is there, you need V. So this half will cancel with half. Here the mass is 1,000. So this 1,000 will cancel with 4,000. So I'm left with 4. 4 square is 16 and 16 multiplied by 4. That is 64. So V square is equals to 64. But we need V. So how to get a V? We have to take root. So when we take a square root of 64, what we get? We get 8 meter per second. So C will be the right answer. So we use the information according to a question in which they mention the lorry and the car has the same kinetic energy. So you just substitute the, like first put the, write the formula, then substitute the values and make subject as V. A force acts on an object and cause the object to move certain distance in the same direction as the force, which row represent a situation in which largest amount of work is done on the object by the force. So work done is actually a product of force and distance. When force is multiplied by distance, we get the work done. So force is 2 and the distance is 40, which makes 80. Force is 10 and the distance is 2, makes 20. Force is 20 and the distance is 6, makes 120. Force is 100 and the distance is 1, so makes 100. So which case we have largest amount of a work done, so that is C. Because the work done is a product of force and distance. And remember, work done is a scalar quantity, so it does not have a direction. A box of mass M slide down a slope of length L and a vertical height D against a frictional force. As a box slide down, the loss of a gravitational potential energy and work done against the friction. Which row gives the loss in gravitational potential energy? So if you want to calculate the potential energy is mgh. So m is the mass of the block, which is given, g is a gravity, but from what height it is moved? it has moved to from a height d, so the potential energy will be mgd. So either A can be an answer or B can be an answer. Then what about the work done? Whenever you're calculating a work done is force multiplied by distance. So what distance you will take? You will always take a distance same as the direction of the force. So which direction the force was acting? The frictional force was acting in this direction. So what distance has moved because of this frictional force, or how much or what force is opposing to this distance? That is L. So what is the work done? So work done will be F into L. So F into L, that's why A will be the right answer. So whenever you're calculating a work done, you need the distance in the same direction. For example, if I say I'm doing a work done and the direction of the force is this, then which distance I should use to calculate a work done? If direction of the force is upward, so which distance I should use? I should use D. But if the direction of the force is along the slope, then we have to use the distance which is in the same direction. So that is L. That's why we use L here. Is it clear? Discussion? So whenever you are calculating a work done, it's force multiplied by distance in the same direction. The diagram represents the energy transfer. A device is 50% efficient. When it is 50% efficient, like this is a Sankey diagram, so 50%, 50 is useful and the 50 is wasted. If I say 100 joules is there, out of 100, 50 is wasted energy and the 50 is useful. So which statement or which equation is correct? The input is useful divided by 2. The input is useful divided by 2. No, that's wrong, because input is useful multiplied by 2. When I multiply useful energy by 2, I'll get the input energy. So this statement is wrong. The useful output and the wasted output divided by 2, that's wrong, because the useful and the wasted should be equal. As it is 50% efficient, means half of the energy is being lost and half of the energy is being used. In C, the wasted output and the useful output are same. That's true. Like the amount which is, if any device is 50% efficient, the amount it use, the useful energy and the amount of energy which is wasted, that will be equal. That's why C is the right answer. Is this clear? Question 5. Moving on to the next question. Remember, when you're calculating a work done is force into distance. But when you're calculating a work done to drag an object, it is force into distance. But when you lift an object, work done is weight multiplied by distance or a height. So here we need, in which exercise is the most work done? Here we are lifting. So what is the work done? It will be weight. Weight is 1 into 9.8 multiplied by distance 1. Because it will be weight multiplied by distance. Here we are dragging, pushing. When we are pushing an object, we don't bother about the mass. Even it's given or not given does not make difference. How much force we applied and what distance we move. So the work done will be 4 multiplied by 1. That is equals to 4. Here it will be 9.8 joules. Because unit of work done is joules. So here it is 9.8. In this one, a 2 kilogram object is lifted. So what is the weight? 2 into 9.8 multiplied by distance, it moved 2 meters. So this will be 19.6 joules. What about this one? We don't bother about what mass it have. What if we are pushing a mass on a ramp? Yeah, that's a good question. If you are pushing the mass on the ramp, I will explain this part D and then I'll answer your question. If you are applying a force 2 Newton and a distance 2 meters, so what is the work done? 2 multiplied by 2, that's equal to 4. So which is the greatest, most work done is in C. What if in the question we are pushing the object on the ramp and they ask what is the work done? So when we are pushing the object on the ramp, the work done will be force applied multiplied by length or the distance moved on the ramp. Like if I apply 10 Newton and the length of this ramp is given, example, 2 meters. So what I will use? I will use 10 multiplied by 2. Or if I know the weight, because in that case, we can use both formulas. If I know the weight, then weight multiplied by height. If I know the mass and using a mass, I get the weight. So weight multiplied by height, I'll get the same answer. If I do weight multiplied by height or I use force multiplied by distance when we are moving on the ramp. Even I do a work done on the ramp or I'm using a formula weight multiplied by height, I'll get the same answer. So both ways it can be used on the ramp. Is it clear? The next is as energy is transferred in different forms, it eventually becomes dissipated. What does this mean? Like the term dissipated means like energy it's being lost or moved to the surrounding. All energy disappear, that's wrong. Energy is like not something will disappear, it's like transferred from one form to another. The energy finally changes to every possible form. No, it's not like, for example, when we burn a coal, a chemical energy produce heat energy and light energy. That heat energy, example, we use to boil the water, rotate the turbine, convert it, like boil the water, turn to steam, rotate the turbine, produce electricity, but it's not converted into all the forms. It's not a nuclear energy, it's not an elastic strain energy. So it's not like all the forms of energy it will convert into. The energy is spread out among the objects and the surrounding. That's true. Like whenever energy change or happened or dissipation, some of the energy left with the object and some of the energy is transferred to the surrounding. That's why C is the, and total amount of energy become less. That is contradictory to conservation of energy. The total energy should not change, it just changes the forms. But if the total energy before was 100, the total energy final should also be 100. So the dissipation of energy means like some of the energy is kept with the object and some of the energy is lost to the surrounding. In question 8, a ball of mass 1.2 is dropped from a height of 30 meters. As it falls, 25% of the potential energy is transferred to the thermal. Like 20, thermal is means like loss. So 25% is being lost. What is the kinetic energy? So first, the ball is having a potential energy. How much is the potential energy? Because these questions are before 2023, so they took a gravity as 10. You can take 9.8, 1.2 into 10, because mgh, the height is 30. So this will make 360 joules. So this has 360 joules of total energy, potential. But while it is falling, it lost 25%. What is the 25% of 360? 25, how to work out? 25% of 360, like 25 divided by 100 into 360. So 25% of 360, that will be equals to 90. So 90 joules, 25% is being lost, so 90 joules is lost. So originally it was 360, 90 is being lost. So how much is the kinetic energy? 360 minus 90, which is 270. So 270 joules of energy it will have. Remaining 90 joules or 25% is being lost. In question 9, a girl hangs by her hand from a bar in gymnasium. She pulls herself up until her chin is level with a bar. The mass of the girl is 48. She pulls herself through a distance of 0.25 and in 2 seconds. What is the power? How to work out the power? Power is work divided by time. or it is force into distance divided by time. And what about the work here? Whenever you're lifting an object, whenever you're lifting, because we need work over time. Whenever you're lifting an object, the work is equals to weight multiplied by height. So weight is 48 times 9.8 is a weight, and multiplied by height, the distance she moved, that is 0.25. Divided by how much time she took? She took 2 seconds to lift her. So what's the answer? You will get about 60, closer to 60, or a 60 joules per second, or watt. So why we use here weight into height? Because as you can see in the question, a girl hang and she pulls herself up. Like she's pulling herself up. She's like lifting her up. So whenever lifting, it's the work is actually the force weight multiplied by height. And to get the power, we need the time. So work divided by time will give us the power. Two cars, P and Q, have different masses and different speeds as shown. Which row correctly compares the momentum and the kinetic energy? Momentum is a product of mass and velocity. 1000 into 10, so that will become 10,000 kilogram meter per second. 500 into 20, that will also become 10,000. So they will have the same momentum. So either B can be an answer or C. But when we calculate the kinetic energy, which is half mv square, so for car P, the mass is 1000 and the speed is 10 square. For this one, the kinetic energy, it will be half, the mass is 500 and the speed is 20 square. So when you simplify, you will find that the kinetic energy of P is less than Q. Like this result will be different from this one. So C will be the right answer. So they have the same momentum. The product of mass and velocity is same, but they have different kinetic energies. A car of mass 800 kilogram travel over a hill. By traveling to the top of the hill, it gained 40,000 joules of gravitational potential energy. Take the gravity as 10. What is the height? So how to work out the height? The potential energy is equals to mgh. The potential energy is 40,000. The mass, it's 800. The gravity they said in the question is 10. So we'll take as 10 and height. So this will be 40,000. This will be 8,000 into h. 40,000 divided by, because this is multiplied, other side it will be divided. So 40,000 divided by 8,000, which is equals to 5. So it rises to a height of 5 meters. Question 12. A lamp has a power of 5 watt and it wastes 1. What is the efficiency? How to work out the efficiency? Efficiency is a useful power or a useful energy or a power divided by the input energy or a input power multiplied by 100. That's a formula. How much is a useful? Because out of 5, 1 is wasted. So how much is a useful? 4. And what is the input energy? That is 5 and divided by multiplied by 100. So it is like 400 divided by 5. So it will give us 80%. Efficiency is in percentage. So it will give us in percent. So 5 watt is there, the total, but 1 watt is wasted. So remaining is 4 watt is a useful. So we always take a useful energy or a useful power when we work out the efficiency. The box contains the names of 8 different energy resources. How many resources are renewable? Natural gas, no. Geothermal, yes. Solar, yes. Wave, hydroelectric, oil, no. Wind, yes. Coal, no. So how many of them are renewable? 5 of them are renewable. And 3 of them are non-renewable. A car starts from a rest and a position X it accelerate. The kinetic energy of the car at Y is equals to gravitational potential energy. What is the height? So they mention here like the kinetic energy at this point is equals to potential energy at Y. So it means the kinetic energy is equals to potential energy. And the speed of a car, the kinetic energy is half mv square and the potential energy is mgh. So we can cancel m with m because if we don't know the mass and mass here will cancel out. So this will become half v square is equals to gh. We'll simplify. So it will be half. V is a speed which is 10 square. G is a gravity 9.8 and then height. So 10 square is 100 divided by 2 makes 50. 50 into 9.8 is height. And 50 divided by 9.8 will give us height. So that will about 5 meter, or B will be the right answer for this. So whenever there is no loss of energy, the kinetic equals to potential. So mass will cancel out with mass. So you don't need the mass for getting the speed. Is it clear, this one? Any question or a doubt? So this was exercise 1 from work, energy and power. Tomorrow we'll do more from this exercise. And topic 2.2 will start, which is about the expansions